modeling of system. So content of today's lecture are electrical system. We will discuss the electrical system in frequency domain and time domain. Then I will take some part of the mechanical system. So the modeling of the system is actually an elemental or mathematical representation of a process or a system. The modeling actually helps in the analysis of the input-output of the system. Like if I am giving any input, then what should be the output? So for this purpose, the modeling helps us. Now the models gives an idea about the dynamics of the system. If initial input is present, then what will be the output if some input is given? And actually the dynamics is related to the evolution of the system variables. Like if I am giving any input, and if some initial input is also present, then what is the output? Like if I am saying that there is some temperature of the room, and if heater is on, then what about the temperature of the room? Whether the temperature increases, if it increases, then how much it increases. So all these detail can be done mathematically with the help of the modeling of the system. So today I am starting mathematical modeling. The mathematical modeling, the types of the mathematical modelings are differential equation model, transfer function model. The modeling can be done by calculation of transfer function and state space variable. So these three methods are used for the modeling of the system. The differential equation models, in this the time domain representation is taken of the system. In this, the dynamic of the systems is represented in the form of differential equation, like dV by dt is equal to R di upon dt. So this is the differential equation representation. Now next is the transfer function. For the transfer function, the dynamics of the system is represented in Laplace form, in Laplace transform. Like in Laplace transform, I can write I upon V is equal to 1 upon R plus L plus 1 by CS, or any value. Similarly, the third one is the state space variable. In this, a set of variables are used to describe the system. Generally in this, the variables are written in matrix form. Like this, di by dt upon dv upon dt is equal to, it can be r by l, 1 by l, 1 by c, 0, or any value. So any set of variables is used to describe the system. Like here I can see current, voltage, resistor, inductor and capacitor. So these are used to describe the system. So this comes under state space variable. State space variable, we will talk about this in unit 5th. Now come to the analytical model. In analytical model, I am talking about the transfer function of a system can be calculated after modeling of the system. This comes under analytical modeling. So for this purpose, I am taking physical systems. There are number of physical systems like electronic system. In this system, the diode, transistor, op-amps are considered. Next is electrical system. In this, resistor, capacitor, inductor and high voltage are considered. Next is hydraulic system. Hydraulic system is related with water. Next is thermal system. Thermal system is related with temperature. Mechanical system. Mechanical system is related with mass, damping coefficient, springs, K, B. This is related with this. So I am taking electrical and mechanical system. In our syllabus, we have to study about the electrical systems and the mechanical system modeling. So first I am taking electrical system modeling. The electrical system, and thus the voltage source or current source can be considered. The voltage control source and current control source can be considered. It means voltage control source or current control source can be given. For this purpose, I am writing the basic elements used in the electrical system. The basic elements, here I am writing for the voltage control source, and here I am writing the basic elements for current control source. Now first one is the resistor. All of you know about this, denoted by R. Inductor, denoted by L. Capacitor, denoted by C. Similarly, for the current control source, the basic elements are resistor, inductor and capacitor. Now the basic system variables are, for the voltage control source, the basic source variable is voltage and also charge, denoted by Q. So the system variable for the current control source are current, denoted by I, and flux, denoted by phi. So voltage is related with the charge and current is related with the flux. Now come to the basic elements for the modeling. I am taking basic elements. As all of you know about this, you have already studied in standard 11, 12th. So I am taking an overview of this. I am taking resistor. There is a symbol of the resistor. If I is the current flowing through this resistor and V is the voltage drop across this resistance. So I can write V equal to IR. What is resistance? Resistance is this is opposing the flow of current. So I can write V equal to IR. If I want to write this resistance in impedance form, then impedance is equal to R plus JXL minus JXC. Now here the inductor is not present, here capacitor is also not present. So I am not taking these terms XL and XC, so Z is equal to R. So this is the impedance of resistance, which I can write equal to Z equal to R. Now next basic element is inductor, obviously denoted by L, as all of you know. This is the symbol of the inductor. This is L, current I is flowing, voltage drop across, let it be V. So the inductor stores the electrical energy. We also know that the flux is directly proportional to current, or I can write phi equal to L I. or we can say the rate of change of flux with respect to time is proportional to rate of change of current with respect to time. So I can write d phi by dt is equal to L di by dt. So as we know, this d phi by dt is actually equal to voltage. V equal to d phi by dt is equal to L di by dt. So this is the voltage drop across the inductor. If I want to calculate the current flowing through the inductor, then I can take the integration on both the sides. So I am taking integration on both the sides, L di by dt. So L को मैं इधर ले लूंगी और I को कैलकुलेट कर लूंगी. So I is equal to 1 by L integration of V dt. Now this much is the current flowing through the inductor. Now next is capacitor, denoted by C. This also stores the electrical energy. So stores the electrical energy. So the symbol is this. Current I is flowing. The voltage drop across this is V. So what I can write, Q is proportional to V, or I can write Q is equal to CV. So if I am taking rate of change of this charge with respect to time, this can be denoted by I, current. This is equal to C dV by dt. So current is equal to C dV by dt. This is the current. If I am taking integration on both the sides, then I will be able to calculate the voltage across the capacitor. So I dt equal to integration of C dV upon dt. So this is the V is equal to 1 by C integration of I dt. So this is the voltage drop across the capacitor. Now I want to write the value of capacitor in impedance form. So Z is equal to R plus JXL minus JXC. So resistance is not present here, inductor is also not present here. So I am not taking these two terms. So J equal to minus JXC. So this is equal to how much? XC upon J. The value of XC is 1 upon omega C. So J omega here is equal to S. So I am writing Z equal to 1 by SC. So impedance of the capacitor can be written as 1 by SC. So this Z, here the Z, this capacitor in frequency domain can be written by 1 by SC. Similarly for the inductor, if I am seeing the inductor, the Z equal to R plus JXL minus JXC. Since capacitor is not present here and resistance is also not present here, so I am taking only this term, Z equal to JXL. The value of XL is omega L. So this J omega is equal to S, so Z equal to SL. So the impedance of the inductor can be written as SL. So if I want to represent this inductor in frequency domain, I can write SL for this. So inductor in frequency domain can be written as SL, in time domain can be written as L. The capacitor in frequency domain can be written by 1 by SC, and the capacitor in time domain can be written as C only. Now I am taking one example of the electrical network. Now I am doing the discussion of this electrical network in frequency domain, that is in terms of S. For this purpose, I can apply either mesh analysis or loop analysis. First I am taking mesh analysis or loop analysis. I can also apply nodal analysis. First I am taking mesh analysis. So for this purpose I am considering one network. This is R1, R2, capacitor C. I am taking voltage VI here, that is input voltage, and the output voltage across resistance R2 and capacitor.